Okay, so as in the last video we have discussed about the general introduction to the mole. What was mole? Mole was basically a bridge which was telling us about the connection between two parameters. The first one, mass of the substance, with the number of the particles present in the substance, and there we discussed in very detail that what are substances. Substances are something which reacts chemically, right? And we have two type of substances, element and compound. Element were made up of atoms, and those two were physically combined together. However, another substance was compound, and compound were made up of molecule. Molecule were physically combined together. However, molecules were made up of atom, and those atoms were chemically combined together. Alright, so in today's video we are just going to um, study something else about mole, or study more about mole, right? What is actually mole? So mole, we have just discussed that it gives us the connection between two parameters. It basically works as a bridge, and it tells us about two things: mass of the substance and the number of particles present in the substance, right? Now, one mole has how many particles? One mole, basically this is a constant value, this won't be changed, right? So 1 mole has 6.022 into 10 to the power 23 particles. 1 mole is how many particles? 6.022 into 10 to the power 23 particles. This is very important in terms of MCQs, alright? So 1 mole has how many particles? It has 6.022 into 10 to the power 23 particles. This value was first, calculated by Italian physicist Emilio Avogadro. Thus, it got the name as Avogadro number. Since Avogadro has calculated this number, that's why the name of this number is Avogadro number, and it is basically denoted by capital N and capital A, that two written down, right? So 1 mole has 6.022 into 10 to the power 23 particles. That value was calculated by Italian physicist Emilio Avogadro, and thus he calculated the value. That's why it has a name of Avogadro number, right? And it is denoted by capital N and capital A, right? So now we are just going to understand in very detail what it is actually, right? So let's take an example of carbon atom. Carbon atom, right? We know that carbon has 6 protons, 6 neutron, and 6 electron. So let me write this: 6 protons plus 6 neutron plus 6 electrons. Now basically I am calculating the mass of the carbon atom, right? And we know that the carbon atom has 6 protons, 6 neutron, and 6 electron. That two are situated like this: 6 proton and 6 neutron in the nucleus, 6 proton and 6 neutron in the nucleus, and 6 electrons are revolving around the nucleus, means they are in the shell, right? So when calculated the mass of one atom of carbon, mass of one atom of carbon, we basically calculate 6 protons, since it has 6 protons, and 6 neutrons, right? We don't calculate, or we don't add electrons to it, since we know that the mass of electron is very small. Let me write the mass here, right? Mass of electron is 9.11 into 10 to the power minus 31, right, kg. And the mass of proton is what? Mass is proton is greater than the mass of electron. Mass of electron, you can see now, minus 31 power, means it will gonna be very small, right? So mass of proton is 1.67 into 10 to the power minus 27 kg, right? It is a bit greater than the mass of the electron, right? And then mass of neutron is 1.674 8 or something into 10 to the power minus 27 kg. Mass of neutron is slightly greater than the mass of proton, but we consider the mass of neutron and mass of proton as same, right? 1.67 into 10 to the power minus 27 kg. Since the mass of electron is very small, that's why we do not take the mass of electron while calculating the mass of any one atom, right? So we just add 6 proton, 6 neutron, and it gives us actually 6 proton and neutron, means 1.67 into 10 to the power minus 27 their mass, right? 1.67 into 10 to the power minus 27. So this value 1.67 into 10 to the power minus 27 is also equal to 1 AMU. Thus I can also write the mass, 6 plus 6 2, since we have proton plus neutron, right? So 6 plus 6, this is proton, 6 neutron, into 1.67 into 10 to the power minus 27, since we know that the mass of electron and proton, neutron and proton are the same, that's why we have written 1.67 into 10 to the power minus 27. So 6, the mass of, or you can say 6 neutron and 6 protons are added, and it gives us 12 into 1.67 into 10 to the power minus 27. We need to multiply, and thus we know that 1.67 into 10 to the power minus 27 is equal to 1 AMU. So I can also write 12 AMU. Alright, this would be the mass of the one atom only. This is the mass of only one atom. Mass of only one atom of carbon, right? But now I want to calculate the molar mass of the carbon. Then how I'm going to calculate the molar mass of the carbon? Let me tell you this now, right? So molar mass of the carbon atom means it is the molar mass, the mass of the 1 mole, right? So we know that 1 mole has how many particles? 6.022 into 10 to the power 23 particles. 1 mole is 6.022 into 10 to the power 23 particles. Means the mass now I am going to calculate of carbon will be not only of one atom of the carbon, however it will be of 6.022 into 10 to the power 23 atoms of carbon, right? So we know that one atom carbon mass is 12 AMU, right? And I need to calculate 6.022 into 10 to the power 23 particles mass. So into 6.022 into 10 to the power 23, right? So I know that AMU is equal to what? Let's write that, right? AMU is equal to 1.67 into 10 to the power minus 27 into number of particles is 6.022 into 10 to the power 23, right? When I am gonna calculate this all, what I'm gonna get here will be 12. This will gonna resolve actually. This is gonna resolve, and thus I'll get here will be gram, right? Grams. So the mass of 6.022 into 10 to the power 23 particles of carbon will be 12 gram. However, the mass of the only one atom of carbon will be 12 AMU. Whenever you're seeing AMU with any numerical value, that is only a mass of one atom, right? But if you are going to see the mass of a lot of values, so it will gonna give you in the grams, right? So basically here we have 1.67 into 10 to the power minus 27. This is in the basically kilogram. When you will be converting this kilogram into gram, you will gonna get 1.67 into 10 to the power minus 24 gram, and then you can resolve it. You'll gonna get only nothing. You won't get anything, right? So it will gonna left only 12 gram. So here I can write this is kilogram. However, when I'll be writing this in the gram, what I'm gonna get is 1.67 into 10 to the power minus 24 gram, right? Same for here, 1.6748 into 10 to the power minus 24 gram, right? So I have just told you in the kg, right? These two are in the gram, right? So this is basically in the gram. So today we have just seen that what would be the mass of the 1 mole of the atom. We know that 1 mole will have 6.022 into 10 to the power 23 particles, right? So when it will have 6.022 into 10 to the power 23 particles, we'll have its mass in the grams, not in the AMU. When you see AMU, it is just a mass of the one atom of any element, right? So here I can also write, I have just written this in the kilogram as well. So it would be good if we write this in the gram. So minus 24 gram, right? So now I hope this is clear. This is also minus 24 gram, and it will be equal to 1 AMU, right? So this was all for today. In the next video we will gonna look into the first formula of the mole, how to calculate the mole, right? That I will be calculating, or that I will be studying in the next video.